Welcome to the Deep Dive, where we extract the most important nuggets of knowledge from a stack of sources so you're well informed, fast. Today, we're diving into a really fundamental question in artificial intelligence. How can machines genuinely understand and reason, not just process data, but truly think like humans? Our focus is on a fascinating field called Sophimatics. It's proposed as a way to bridge this pretty significant gap between what AI does now and what human level cognition really involves. And it does this specifically by zeroing in on three key things: meaning, sense, and context. So, our mission today is to unpack the core ideas of Sophimatics, drawing heavily from the insightful work of Gerardo Iavani and Giovanni Obana and various studies they reference. This isn't just about getting lost in technical jargon, it's really about understanding what makes human thought so unique and exploring how we might actually teach that to machines.
Absolutely. And what's truly eye-opening here, I think, is how this deep dive is going to reveal some, well, surprisingly direct parallels between how we learn and adapt as humans and what's absolutely necessary for the next wave of AI.
Mhm.
It really helps us pinpoint exactly why traditional AI approaches often fall short when it comes to genuine comprehension, not just calculation.
Okay, let's unpack this foundational challenge then. The central idea, the premise of Sophomatics seems to be that meaning, sense, and context are just as vital for AI to operate meaningfully as they are for our own reasoning. It's so easy for us to take these incredibly nuanced parts of how we think for granted, but they're actually really complex.
They really are. And that's the sticking point for a lot of current AI. Without these elements, you see, traditional algorithms, well, they operate with pretty predetermined outputs.
Yeah.
They simply lack genuine understanding. That's precisely where Sophomatics aims to step in. And what's fascinating is how some quite foundational cognitive psychology research like Godin and Babley's work helps illustrate this point really well.
Ah.
You're talking about their intriguing research with the SQUB divers. That's a classic example of context playing a huge role in our own memory, isn't it? They found that divers recalled words much better when the environment, the actual context for recall, matched where they first learned the words. So learn underwater, remember better underwater, learn on land, remember better on land.
Exactly. Now, if we connect this to the bigger picture for AI, it tells us something crucial. For any AI system to achieve truly grounded reasoning, it needs contextual data not just fed into it, but deeply embedded within its very framework. Sophomatics argues that context, in this view, isn't just passive background info, it's an active feature. It actively shapes how the AI comprehends and constructs meaning. Okay, so we've established how vital that external context is for AI to truly get it. But what about our internal world? What we find important? That brings us to another really interesting aspect of human understanding that Sophomatics is trying to tackle: personal relevance. Think about it, you're in a super noisy room, maybe a party or something. Despite all the chaos, you can instantly tune everything out if you hear something important, something personally relevant, like your name.
Right. And Treisman's groundbreaking work offers a fantastic illustration of exactly this. She discovered that an auditory stimulus, even if it wasn't the loudest thing happening, could effectively drown out other sounds if it was personally relevant. Like hearing your own name, as you said. A word that was relevant in that specific situation could be picked out and remembered over everything else, even things that were objectively louder.
So, how does Sophomatics propose that AI learns this kind of, well, almost intuitive filtering? It sounds incredibly powerful, definitely, but also seems incredibly complex to program into a machine.
Oh, it is complex, no doubt. But the sophimatic insight here is this. If a cognitive AI can perform what they call relevance filtering, basically, figuring out what's important to itself or its current task or environment, then its entire output, its behavior, can align towards a specific target or goal. This makes it a truly dynamic process, you see, which is a stark contrast to more static AI, which just can't really grasp these relational properties of context and personal relevance. So relevance filtering becomes a major pillar of the Sophomatics model. It enables dynamic system adaptiveness, not just rigid, pre-programmed execution.
This brings up an important question, though. We often think of meaning as something fixed, something you can just, I don't know, look up in a dictionary. But for us humans, how does meaning truly arise? It feels much more fluid than just a static definition.
That's a critical distinction, absolutely. For humans, meaning arises situationally, dynamically. It's like a product of how our minds associate various different aspects with a stimulus or a situation at that very moment. And this is precisely where many current generative AI models tend to struggle. They can be oversensitive to, let's call it noise, associated with contextual ambiguities. They often lack that deep human-level context sensitivity. Sophimatics defines meaning not as some fixed definition, but as a relational construct. It arises from the relationships, the connections between different pieces of information, the context, the relevance, the current situation. It's more like a living, evolving network of connections rather than a fixed dictionary entry.
Okay, I see. And this is exactly why Sophimatics is positioned as so vital then. It provides the discipline, the framework needed for computationally reconstructing meaning as that dynamic relational construct you just described. So how are AI researchers actually trying to build systems that reflect this? Are there specific architectures or approaches that are helping bridge this gap?
Yeah, that's where hybrid approaches, specifically symbolic connectionist AI approaches, shows some significant promise for, let's say, grounding this idea of a contextual model.
Okay, hybrid symbolic connectionist. Tell us a bit more about that. How do these hybrid systems actually work?
Well, a good example comes from Vromter and Lannert. They developed an architecture that quite elegantly integrates localist and symbolic networks. Their model basically uses three different layers. There's a neural layer handling the raw, distributed pattern recognition, like the initial sensory input. Then a localist layer identifies specific distinct features within that input. And finally, a symbolic layer abstracts these features into higher-level concepts and logical relationships. It's this multi-layered structure that lets the AI recognize different levels of complexity in the data, from the sensory details right up to abstract ideas.
That multi-layered approach does sound incredibly powerful. So by capturing these different features, structural, semantic, relational, across these distinct layers, what's the actual breakthrough? How did that help the system handle, say, novel inputs, things it's never specifically encountered before?
Right, the real Sophimatic insight here, I believe, is that robust meaning-making in AI isn't just a single computational step. It's more like a dynamic dance across these different levels of abstraction. It's this orchestrated synergy, this interplay between the layers that allows the system to correctly process data, make sense of it, and crucially resolve semantic ambiguity even for novel input stuff the AI hasn't explicitly been trained on. And this really supports that Sophimatic principle of meaning emerging from integrated layered processes. It fundamentally outperforms those, flatter, classical AI architectures that just can't manage this kind of complexity.
Okay, let's tackle another classic challenge, one humans handle pretty well, but AI often trips up on: ambiguity. How do we manage ambiguous sentences? Like Sloman's famous example, they watch the man with a telescope. We usually figure that out without much trouble.
Yeah, that's a great example. And it's because traditional AI often just assume sentence interpretation is all about parsing grammar rules. But Sloman's work in what he called computational epistemology, which is basically the study of how knowledge is represented and acquired computationally, shows that sentences can have multiple valid interpretations depending entirely on context.
Yeah.
His solution involves, constantly evaluating new interpretations that can be attributed to existing information stored in the system's memory. But more importantly, it requires the ability for current perceptions, the incoming data, to actually restructure previous interpretations held in memory.
Wow, that sounds remarkably human-like. Like how we adapt our understanding on the fly. It's not about finding one static answer, but maintaining this dynamic, evolving understanding that gets updated by new information. That ability to restructure interpretations must be absolutely key.
It is. It's all about dynamic interpretation, not static parsing. New information has to directly impact the system's current state, and critically, its ability to adapt for whatever comes next, for future interactions.
So if context and meaning are this crucial and the system needs to be dynamic, how do AI systems actually organize and categorize the potentially vast amounts of data they encounter? What provides the structural backbone for this kind of intelligent understanding rather than just rote memorization?
That's where ontology-driven categorization comes in. It provides a really robust and computationally efficient framework for handling this. There's work by Mayer and colleagues, for instance, with an embodied cognitive agent like a robot navigating the world. They demonstrated that explicitly building ontological structures into the AI's programming allows the system to categorize data much more effectively. It does this by incorporating both context and the relationships between different pieces of information. Without this structured ontology, the agent made significantly more errors.
Okay, so ontologies essentially formalize knowledge hierarchies. When you say formalize knowledge hierarchies, are we talking of systems that kind of map out how different concepts relate, like a really sophisticated family tree for ideas rather than just a list of facts?
That's exactly right. Think of ontologies not just as a dictionary, but as a highly structured, interconnected web of concepts. It's like a semantic roadmap for the AI. Is how a system can understand that, say, apples and oranges are both types of fruit, which are a type of food, and how these relate to concepts like nutrition or shopping or farms. This hierarchical relational understanding lets AI move beyond simply recognizing individual data points, what we sometimes call token-focused algorithms these days, and allows it to infer these higher-order relationships, just like we do when we categorize and make sense of the world around us. And crucially, these systems can then adapt more effectively to the environmental context they find themselves in.
Right. We've covered quite a bit here. Context sensitivity, relevance filtering, these multi-layered architectures, dynamic ambiguity resolution, and now ontological embedding. It feels like we've touched on a lot of really crucial pieces of the puzzle.
And this brings us to a really important point. Many current generative approaches, as powerful as they seem in some ways, simply don't account for all these combined requirements working together. To truly emulate human sense-making, to get towards human-level AI, all these frameworks, context sensitivity, relevance filtering, ontological structure, dynamic interpretation they have to function synergistically. They can't just be isolated modules. Sophimatics is essentially presented as the unifying discipline, the approach that tries to weave all these necessary elements together into one cohesive functioning system.
So it sounds like by embedding meaning, sense, and context, not just as inputs, but as core operational features, we're not just talking about incremental improvements in AI performance. We're really talking about creating that fundamental paradigm shift that Sophimatics is calling for. What an incredible journey into Sophimatics this has been. This deep dive has really highlighted, I think, the intricate dance between meaning, sense, and context that underlies both how we think and how truly advanced AI might one day operate.
And if we connect this to the bigger picture, maybe step back for a second, it raises a pretty profound question, doesn't it? As these AI systems become more adept at understanding context and relevance, maybe even mirroring some of our own cognitive processes, well, how might our own understanding of human consciousness and even how we learn evolve in turn?
That is a powerful thought to end on. Thank you for joining us on this deep dive. We definitely encourage you to continue exploring this fascinating and rapidly evolving frontier of AI.